Hey, you guys. Hope you're having a great snow day. So, wanted to just give you a little bit of instruction on how exactly you're going to do your assignment today, because it's kind of a different type of notation than we have seen before. So, you're going to take that same diagram that we've been using over the last couple of days with our different versions of the same element here. And I want you just to sketch for yourself a little, it's almost like a little mini version of a periodic table tile. Because if we think about carbon and really carbon 12, we kind of already calculated these over the last couple of days, but our protons are going to be 6 for that carbon 12. And so when we go to write the chemical symbol with kind of our different isotope pieces factored in, we want to make sure that we're writing down what element we're dealing with, which would be carbon, and that's going to be determined by the number of protons. So we're going to write down the chemical symbol for carbon, which is C. And then to the left and bottom of this tile, we're going to write in how many protons are included in that nucleus, in that atom. And then in the top left corner, because this is carbon 12 and our atomic mass is 12, we're going to write a 12 in this top left corner here. So the final chemical symbol for this particular isotope, this carbon 12, would be a 12 top left, a C right here, and then a 6 in that bottom left-hand corner. Same dealio for your carbon 13, your carbon 14. Either way, I mean, you guys told me over the last couple of days, we're dealing with 6 protons. So either way, we're going to be dealing with carbon. We've got the same element going, but the only difference after we get our protons in there, the only difference is our atomic mass, okay? So if you look at your assignment for today, our notation and practice here, you're going to go through and do the same thing with the elements that are shown here. So let's say I'm dealing with 8 protons. I'm going to go into that, and if I look at my periodic table, I know that 8 protons is the element oxygen. And if I look over here, the element with 9 protons is fluorine. So I'm going to take those chemical symbols there, and I'm going to make sure that I have included whatever the number of protons is, which in oxygen's case would be 8, and in fluorine's case would be 9. And then we're going to come up here and we're going to figure out what would the atomic mass be. If I have 8 protons, 8 neutrons, that should give me 16 particles in the nucleus. And over here, if I've got 9 protons and 10 neutrons, that should give me 19 particles in the nucleus for my fluorine. So in your instructions here, it tells you that you need to decide if the pair of atoms here are different elements or if they're different isotopes of the same element. So with that, and if you want to highlight it or if you want to do a little text box, or I mean, I don't know how you want to do that. Maybe you even just draw a little shape here. But if I've got entirely different elements here, it's not just a different version of the same element. We're dealing with atoms of different elements, okay? So that's kind of how you're going to answer today's assignment.